Hello, I'm Matt Eland. I am Integer Man on Twitter. Please give me a follow if you use that platform. And I'm going to talk to you today about one of my favorite libraries, not just for the .NET framework, but for really any programming language in general. As we'll see at the end, this is supported for a great many deal of different technologies and languages. But I'll be showing you today the Scientist.NET implementation of the Scientist library. So this is Standback. I'm going to try Scientist, and I'll tell you what that's all about in a moment here. But first, some things about me. I'm an instructor at Tech Elevator. We are a software development boot camp located currently in 6 places: Cincinnati, Cleveland, Columbus, Detroit, Pittsburgh, and Philadelphia. I am an instructor in the Columbus campus, which I thought was going to look a lot like this, but given coronavirus and our current state of self-isolation, teaching looks a lot more like this right now, which is fine. We still do fine, but life is interesting at the moment. Before that, actually about a month ago, I was a software engineering manager, and before that, a developer. And I did a whole lot of development, probably about 15, 16 years professionally, but really longer as a hobby since about 1987. And I generally tend to work with .NET technologies, C#, F#, as well as some JavaScript technologies. Really, we should be adding Vue to this, as I've really taken a liking to that recently. After that, after I graduated from development and added management to my stack, I aspired to earn the title World's Weirdest Boss. I don't really think I came close. My employees or former employees might argue that point, but I did become pretty good at isolating technical debt and thinking about software quality and just taking a look at where the problems we have in software are, as well as how to fix them and how to fix them without introducing a whole lot of new defects. And I looked at a lot of different libraries in my journey to really pay down technical debt while ensuring software quality. And honestly, the biggest game changer for me was, Scientist. So in this talk today, I'm going to be talking to you about Scientist.NET. We'll start with kind of an overview of what this thing is, how it works, and what the workflow is when we start to use it. And then we'll drill into really a kind of standard example that I like to give about how to adopt Scientist into an ASP.NET Core code base. It doesn't have to be ASP.NET Core, but my example today will be in that framework because it is popular. We'll talk about some advanced science use cases, just kind of things you may want to consider using if you adopt Scientist, but you don't necessarily have to. And we'll end with a discussion of reasons why you might not want to use Scientist. Everything has its trade-offs, and Scientist has a few of those as well. But my hope is that you will at least consider using Scientist in your stack, but make an intelligent decision about it. So with that, let's talk about what Scientist is. So Scientist is really, it's a tool designed to solve a problem. And the problem that we're trying to solve here is if we have an application that has a wide variety of potential inputs. Those inputs can be complex, diverse, and it's really impossible to test for every user in the system, as well as every type of thing the user might put into the system. That's where we start to get into the complexity where, okay, we can write unit tests, but are they really going to be adequate for covering everything that the users can throw our way? On top of that, if we're in a scenario where we cannot accept any sort of a regression failure or an additional issue, then this is a place where Scientist really comes in handy. Think of financial systems, so systems calculating a bank loan or insurance prices, things like that. Or even things like medical or something, maybe even just potentially impacting to a person. Like our example today will be a resume processing application. You wouldn't want to introduce a bug that limits somebody's ability to get a job, potentially. So for these types of scenarios, Scientist is very helpful. And let me show you why. So with Scientist, you have some code, which we're going to call the client. And let's say it was talking to a legacy routine, something that's buggy, we don't like it, we want to replace it with something else. Okay, so this legacy routine is the code we're getting away from, and we want to migrate to something else. Scientist is going to help us with that. And so what we'll do is we will replace this legacy routine with a call to Scientist. So our code now calls out to Scientist, And what scientists in turn will do is it'll call out to the legacy routine. And let's say that we're calling out to a calculator, so an add method, for example. So client will call out to scientist. Scientist will run an experiment, call the legacy add function, and return the results of that calculation. Well, okay, so what's the big deal? You're adding another layer of abstraction and complexity, and you're returning the same result. I don't see much value in that. Well, the value comes in because scientists will also call out to your new routine. So it calls out to both the legacy routine and the experimental new implementation of that routine. And it will always return the result of the legacy routine. And why that matters is if we introduce a new routine that is buggy, potentially, then the calling code does not see that error. It doesn't see the inaccuracy. It doesn't see any exception being thrown in that new routine. It just carries on its merry way. This effectively isolates problems in that new routine from impacting the external caller, or the original caller of the legacy routine. Make sense? Now, the cool thing here is that Scientist doesn't just ignore these results. What it does is it compares them and it ships them off to something called a result publisher. So any calculation that it's doing using the experiments will go off to a result publisher, and the result publisher can do something with it. Let's say it reports it to us somehow. Well, that's useful information. We know, like, hey, for this input, the legacy routine returns this, and the new routine returns that. These things aren't the same. Okay, somebody take a look at this at your leisure, and then try to figure out, what the problem is. Okay, so here's the problem. Okay, so now we'll be able to fix it, right? So now you deploy a fix for that, and then all of a sudden you get the same input, and scientist is happy, and the legacy routine is happy, and you have a pretty high degree of confidence over time that your new routine is going to be as good or better as your legacy routine. And once you're happy with that, what you'll do is you will remove scientist from the equation as well as the legacy routine and the result publisher, and what you'll be left with is just the client calling the new routine. Well, you could have fast forwarded to this step, and that's what most people will do, is they'll go directly from the legacy routine to the new routine. And sure, they'll do a lot of testing, but the steps in between let us isolate the potential failures and weaknesses of our new routine without anybody ever having to see those failures except for us as developers. And when we do see those, it was actually a fairly low-stress kind of a scenario. So that is really what Scientist does for us, is lets us scientifically, sorry, pun intended, tweak our routines and algorithms in a way that isolates bugs from the end user. Cool. So let's dive a little deeper, and we're going to be talking about a piece of legacy code that I mentioned earlier, our resume processor. So this resume processor takes in a resume in some form or another, and it takes in a job opportunity, and it will calculate a score based on how qualified that applicant is for that opportunity. So that's kind of cool. Now, if you're familiar with production systems, most production systems will look something like this in their architecture. In order to keep things a little bit more understandable in this talk, I'm going to keep things simple, and we'll have a nice and simple architecture that's a little more simple than you'd see in the real world, but it'll let us focus more on scientists and less on typical code. And so what we'll look at here today is this application architecture where we have a processor, an ASP.NET controller on the left, and a resume processor in the middle here. So this is our main application logic, as well as some supporting domain models and things like that, data access layer, etc. So we're really going to be looking at this code in the middle, and we're going to be pretending that this code is pretty bad. By the way, this diagram is generated by a preview version of Independ, which was given to me by its creators just as an evaluation. I really like this new visualization tool. I think it's really, really cool to be able to look at the overall structure of your application and zoom in as needed and see dependencies. So check it out at independ.com. Really, really big fan of this for anybody with an architectural mind who works with .NET applications. But let's get a clearer view of this. So let's zoom in a little bit and take a look at our exact scenario. So we're going to be looking at this resume score in the middle. and we're gonna pretend that this code is awful, it's brittle, we don't want to work with it, and it's just bad in general. And so what we're gonna do is we're gonna take a look at all the reasons why we're afraid of changing it. And these are kind of our normal things, like the code is brittle, we don't understand it, the person who wrote it is gone, there's no documentation. Yeah, there's tests, but do they really test all the scenarios we're going to see in production? Are there really valid tests? That kind of a thing. So for whatever reason, we've decided to write off this component and rewrite it. And because of that, we're going to be adopting Scientist. And because, this talk is about Scientist, so it can be kind of boring if we decided not to adopt Scientist for it. So when we are adopting Scientist, we're going to go through some basic steps. So first of all, we're going to be installing the Scientist package via NuGet, and then we're going to be kind of wrapping our code that we were going to replace into something that we can extract and replace with a new implementation. Then we'll write that new implementation, which we're going to gloss over here today because that's not really our focus. And then we're going to devise a test to compare the old implementation and the new implementation. Finally, once we're happy with the functionality of the application in this new state, we'll deploy it to production and observe things coming in. And once again we're happy with the way that's handling, we're going to remove Scientist from the equation and as well as our legacy code and switch entirely over to our new rewritten, shiny, efficient, wonderful Logic 2.0. Okay. All right. So installing Scientist via NuGet. What you do is you right-click in Visual Studio and Solution Explorer on your project, and you say, hey, I want to manage NuGet packages for the solution, and you go in here in Browse, and you just type in Scientist, and you'll get results that look something like this. And what you want is that top line, the Scientist, and you'll just click Install, and it'll install it right into your application, and you'll be able to use Scientist from there. So next, I mentioned earlier we're going to encapsulate our legacy code. All right. So this code is the code that we're trying to remove, the yellow code. We're trying to swap it out with something else. So we need to take a look at anything that's using it because we need to isolate it from those dependencies. In this case, we really only have a resume controller that's actually using it. And so it's going to be fairly easy to isolate. Honestly, it's actually already fairly isolated in its implementation. So if you're familiar with Web API controllers, they look something like this, right? So you have an HTTP post or GET or whatever, a route, and a method. And then all the way at the bottom down here, line 20, we have this score, evaluate, resume for opportunity. This is actually where we're using our resume scorer. It's really the only line we're using our resume scorer in my sample application. And so this is really what we want to isolate from the rest of the application. Now, thankfully, ASP.NET uses something called Dependency Injection, which I'm not a fan of the name of, but I love the concept. And what it says is, like, hey, I need an iResume scorer, so I'm going to ask ASP.NET Core for the appropriate concrete class for a resume scorer. And that's configured in startup.cs in the configure services. So here we have this line, add transient, so every time I need a resume scorer, an iResume scorer, it's going to create a new instance of resume scorer in this case. So you can look at this as, when I see iResume scorer, give me a resume scorer. And we're going to say add transient, which means just, hey, build a new one every time you need one. So that's kind of what's going on there. So because we're going to be making a new one, I'm going to rename the resume scorer to legacy resume scorer, and I'll create an improved resume scorer. Now you might think that I might just switch over here to improved resume scorer, but remember we want to use Scientist. So I'm going to be creating a new Scientist resume scorer, and I'm going to be substituting that in for iResume scorer. So this is just a simple class that implements iResume scorer. And what it actually does is it creates a legacy implementation and a new implementation. And then it's just going to be using these two implementations for its science experiment, which we'll take a look at in a second here. So now anytime that we need this iResume score, it's going to give us a Scientist resume score because we configured it that way in startup.cs. Okay, so we create our science experiment. So this is the method inside of our scientist resume score that actually generates the score. So you see this line right here, scientist.science. This is telling us, like, hey, go ahead with your science experiment, but your science experiment will return a decimal return type. Okay, cool. That's nice. Also, you're going to need a name for the experiment. This is an arbitrary name. This is only used for differentiating things if you're running multiple experiments inside of the same application that are all going to the same result publisher, which we'll talk about in a minute here. And then finally, we give it a lambda expression here, which tells it how to configure the experiment. And this code can get a little complicated, a little intimidating because it's also using expressions, but it's not too bad if you just take it line by line. So let's take a look at line 7 here. So here we're saying experiment.use. So what's saying, when you see .use, that means this is the value that will be returned to the client. This is a legacy value. So when you say experiment use, it's going to run the legacy implementations, the legacy implementation of evaluating that resume. Okay? And then it'll return the results at line 5, which will then be returned from that whole method. Now line 9 is where we say experiment.try. So this is what's actually representing our experimental logic. So here we're using our new score, and we're going to make it the same call to evaluate resume for opportunity. You can have multiple try statements in Scientist. However, Scientist does, in its documentation, recommend that you only use one. Now, the way it implements things, it kind of forces you to assume that there are going to be multiple results potentially, but they do strongly recommend that you only use one try and one use. I believe they actually enforce only one use because you can only return one thing from your method. So let's say we do all this, and now we say, okay, cool. Well, let's try out our logic. Let's see if the new implementation returns the same as the old implementation. So you go ahead and you go out and you run your application, and you give it a bunch of inputs, and you're still getting the same outputs. So no changes in behavior. Okay, well, at least it's not broken, right? Well, shouldn't mismatches be logged? I know there's some cases that should be logged here, and you're finding out, well, no, I'm not seeing anything getting logged anywhere. And so you hunt me down and you give me a talking to from hopefully 6 feet away or more, and you ask me what's going on, and I'll tell you. Well, remember that Scientist uses a result publisher, and this is an iResult publisher. By default, Scientist uses an in-memory result publisher. This is a fairly useless object for production scenarios because all it does is it just stores the results inside of that instance for you to debug them if you want to. So you can set a breakpoint and get scientist.result publisher and then drill into its internal state and get your results. Hopefully you're not doing that. Please don't do that. Instead, you're going to need to write a custom result publisher. So in this case, we're going to write a console result publisher. And let's take a look at what this entails. It's fairly simple, but the syntax can be a little intimidating, which is unfortunately common in Scientist. So everything in Scientist for a result publisher relies on this iResult publisher interface I talked about earlier. And that just defines a single method called publish. It takes in a T and a T-clean generic argument. This is really the return type and a cleaned return type, which I'll talk about later. And that just gives it a result. And we're just returning a task. It returns a task to support asynchronous operations if you want it to. Our example here won't do that. But let's just take a look at how this works. So first of all, we're going to take a look at the experiment name. So we're going to say, hey, result.experiment name. We're just going to log that out. This is the string that we passed into Scientist when we were running our experiment earlier. So next we're going to look at, hey, did the result match? So we have this matched and we also have a mismatched property. These are just really the inverse of each other. And if it did match, we're just going to say like, hey, this is fine, no worries. But if it didn't match, we're going to say like, hey, there was a mismatch. The control value, that's the result, the value returned by the use statement, remember? The legacy value, result.control value. So, hey, there was a mismatch. The control value was this, and then we have this thing called observations. So we're going to loop over the collection of mismatched observations. Remember I said that Scientist does support multiple tries if you want to, but they recommend that you don't. So here's where we'll loop over those mismatched observations. So each one of those tries that failed is going to be in this mismatched operations collection. And we're going to say like, hey, this observation had a value of this, and then finally at the end we're going to return a task.completed task because we have to return a task, and we're not doing anything asynchronous here. So this is our very simple console result publisher. We'll talk about some other result publishers later on, but let's just show you how you would work with this. So next, we're going to go back to startup.cs where we configured the Scientist result resume scorer, and now we're going to say like, hey, the result publisher is a new console result publisher. And now when we run our application, we make a request and we get something logged. We say like, hey, I have a science experiment. Here's its name. This thing mismatched. The control value was 0, so this should have returned 0, but your new implementation returned 42. Like, dude, you did something wrong here. So you can use that kind of a thing, and this might not be terribly useful unless you're like aggregating your logs from the console, which many people are doing actually in Docker. But this shows you kind of a conceptual level of what a result publisher might look like. So next, we're going to deploy and observe it. So we'll push Scientist out there to our application server. So just deploy this code, and when things come in, so bugs come in, it's going to get logged to the result publisher. A developer is going to see it hopefully, and they're going to say like, okay, well, this is not urgent because it's not impacting anybody's day. They're still able to conduct everything that they're trying to do. They're not even seeing a bug or aware that there's a bug. But when I get a spare moment, I'm going to fix this thing. So, okay, well, let's fix it, and we'll deploy again. And oh, no more bugs are coming in. So everything else seems to be matching fine. So next release, let's just remove Scientist, and everything's going to be great. And when everything's great, hopefully there's profit. Probably that's not extra money. Probably that's just more peace of mind, and you don't have to deal with as much legacy code, which can be more productivity, which can be a form of financial gain, because your resources are more effective in your development team. All right, let's shift gears a little bit and talk about result publishers in a little bit more depth. So while Scientist doesn't ship with a lot of result publishers out of the box, which is one of my greatest pet peeves about it, it does have a great degree of flexibility with this iResult publisher interface. So we talked earlier about a console result publisher, but let's talk about some other things that you might want to build result publishers for, depending on your needs. So the most obvious one to most people is going to be the database result publisher. So you can write a database result publisher to publish to whatever database schema you want. So you can write a SQL Server database result publisher, you can write a Couchbase result publisher, or a MongoDB, or Azure SQL, or Cosmos DB, or any of these things. So you can write something that has tables specific to your needs, but you do have to implement yourself, which is unfortunate. So that's the most obvious thing to people. One I would tend to recommend in favor of this actually is going to be an error tracking service result publisher. So you can take this and you can log to the error tracking service of your choice. I really like Raygun. I really like Rollbar. LogRocket's up and coming and advertising like crazy. But whatever you like, you can just send it off to that particular error tracking service. And then these services will usually, track the frequency of these errors. They'll track the details associated with them. They'll notify your development team. They'll often let you create an issue in Jira or something out of them. This would be my recommended go-to way of tracking an error. But you're going to have to build your own result publisher for whichever service you like to work with. Because, again, there's not a whole lot out of the box. All right. You can also send it off to Google Analytics if you wanted to. That's a decent place to ship things to. So let's talk about some advanced use cases for Scientist. So let's say you're not returning a decimal. Let's say you're returning a custom object like a resume evaluation result. Well, Scientist is going to try to compare these things to each other And the default comparison in .NET is going to be equality comparison. It's going to say like, hey, this instance of resume evaluation result is not the same memory address as this other one, so they're not equal, so I'm going to fail this. Well, they might have the same score. You probably don't want to do that, right? So what you can do is you can give scientists a way of saying like, hey, here's how you compare these two things. So I want you to check the result, so that's the control result score against the evaluation result score. And that's how I want you to compare the results. And it's like, okay, well, you're not mismatched anymore. You got the same score. Cool. So that's really how you would tell scientists a custom way of comparing things. You can also give it an iComparator interface. Usually this is fine enough for most people's needs, and it looks cleaner anyway. You can also pass context to scientists, to the result publisher. So in our console application, or console logger earlier, we didn't really have any information about the inputs. Well, that's a problem if you're trying to reproduce an issue. So what you do is you say like, hey, I'm going to give you some context. So here's the resume this is associated with. Here's the opportunity it was associated with. And then you go in over here and you say like, hey, all right, my result publisher, well, I need to get that resume out of the context. So, okay, here we go. And now I can just work with it as needed. Okay? If you're nervous about putting scientists into production, like I was initially when I first started doing things, you can use scientists with your existing unit tests. You can use it to compare the old version and the new version of things for a random variety of inputs if you wanted to. The way this works is you just write a science experiment that your unit test will talk to, and you're going to set a custom property on your experiment. And once you set that, which I'll show you in a second, mismatches will actually fail your unit test by throwing an exception. And that's really actually all unit test failures are. It's just like, hey, an exception was thrown I wasn't expecting. Okay, I'm going to react to that by failing the unit test. That's all the assert libraries are doing, which is kind of interesting to think about. So what you do when you're configuring your science experiment is you set this throw on mismatches property to true. And when you do that, it's going to it's going to cause that to throw that exception on a mismatch instead of just kind of quietly sending it off to the result publisher, and that will in turn fail your test. I've talked earlier about asynchronous support in the result publisher. Scientist also has asynchronous support built in for invoking the science experiment. So first thing we'll do is we're going to call science async, and then that will return the results, which we'll have to await. And so we'll shift our return type rather to an asynchronous task of a specific type. So we need to do science async for this instead of just science, and then everything else pretty much just works the way you would expect it. So let's talk about some high-level other tricks you can do with Scientist.net. If you're curious about these, you can kind of read more about that on their online documentation. So you can say ignore when you're configuring your experiment to have scientists ignore mismatches that match certain parameters. So you can say like, hey, if you see a mismatch and it's from the user Betty Smith, don't worry about it. She tweaks some custom things. We're expecting errors. Or this is a test user. This is a junk data. Or so we know this is not supported yet for this sort of type of scenario. In reality, you probably won't use .ignore too much. What you may use is enabled. So Scientist advocates using enabled to determine if the experiments should be run at all. And so here you can check a configuration flag to just quickly disable Scientist globally if you want to. Probably a good idea if you want to kill switch for it. It'll just call to the legacy routine and just return the result for that if enabled is false. The other thing you could do is you can use some sort of a random number generator or beta user kind of a flag and just say like, hey, I'm only going to run science results or science experiments 5% of the time. Just a random sampling kind of a thing. Sounds scientific, right? So you can use this to kind of ease into Scientist if you want. Maybe only use Scientist for internal users or something like that at first. Kind of a comfort factor. I mentioned some custom code that goes into Scientist. I've never had any issues with Scientist itself, but the code that I provide Scientist for things can cause issues, and for that, you can look at Throne, and it'll help you handle any errors that you might cause in your iResult publisher or inside of your comparator, or other pieces of logic you might give Scientist. So Throne will help you handle errors in the custom logic that you give Scientist. I mentioned earlier T and T-clean inside the result publisher. Remember, T was the result type. Well, T-clean refers to the result of the clean function if you call into clean. So remember the resume result function. Well, let's say we don't really want Scientist to track the whole request. We just want to look at the result. So you can say clean, and it's going to take that and let you drill into just the score property, for example. And then that will just provide the score directly to the result publisher. It saves a little bit of in memory, and it can help your logic be cleaner, which I guess is where the clean name comes from. I've never used this, but it's an option, and you can check out in more detail on their GitHub site. Scientist does ship with a fire and forget result publisher. This is a result publisher that will just kind of asynchronously launch a different result publisher, which will then do other things. This is useful if your result publisher is going to do something that's going to take a lot of time, like inserting directly into a database. So you just kind of wrap your result publisher inside of a fire and forget result publisher, which follows the decorator pattern if anyone's familiar with that. And then Scientist takes care of the rest. I mentioned asynchronous Scientist, and I mentioned that you can use multiple experiments, not just the one. Scientist will actually allow you to run parallel experiments, so you can specify when you're doing science async how many to run in parallel at maximum. Again, they advocate for only using one experiment and one use, so potentially you could use this to run them both in parallel asynchronously. All right, so now that we've talked about what Scientist is and what it does and why you would use it, as well as some advanced use case and a basic use case for it, let's talk about some basic objections to Scientist, because there are some, and potentially you've been watching this and already thought of a couple of them. So one obvious objection to Scientist is its complexity. So think about it this way. If something is broken in production, would you rather your routine look like this or like this, right? In my experience, I've never known Scientist to have issues of itself. That library is solid, it's good. However, the issues I have had have been caused by running the legacy routine and then the new routine, or vice versa, or them in parallel if we're doing the parallel run of things. This is because Scientist will, it just invokes your code. And if your code does things that cause side effects, well, guess what? Those side effects happen. So let's talk about that, right? So let's say that our resume processor sends an email, or it makes inserts something into a database, or it makes an external call to some service to bill you for the usage or something like that, right? Well, your legacy version is going to do that. And if your new version has the same logic, well, it's going to do that too. So you're going to get 2 emails, and you're going to get 2 billing calls, and you're going to get 2 database inserts, right? That's probably not what you want, and that's potentially pretty bad. So you need to be aware that the code that you give Scientist to execute, it will execute, and that can cause side effects if you're not thinking about what your code actually does. So let's look at this a little bit more and talk about some options that you have. So let's say this is our legacy processor, right? Our legacy resume scorer, and it says down here, line 14, it says like, hey, is this a good score? Okay, well, you're a good match, so I'm going to send you an email saying like, hey, you're qualified for this, or oh, you're not so qualified, so I'm going to give you an automatic rejection message or something like that, right? So what we can do to work around this, the most obvious thing we could do is we just bolt on another property. I'm not too wild about that, but you could do it. So now we're adding a should send email to our resume scorer. And then, in this case, you would set this to true for your legacy version because you want it sending the emails. And your experimental version, you say, okay, don't actually send the email. You're just a preview. It's okay. Or only send it for beta users or whatever, something like that, right? So you can use a property and configuration property. That's one option. The other option is you could rely on dependency injection for it. So if your legacy resume score, or your resume score in general, relies on an email notifier, well, okay. Now you can either give it null and write your code in such a way that null is acceptable for notifier, or you can give it a fake email notifier to the ones that you don't want to actually send the emails. So you can take this style of approach for things that insert to databases, make legacy calls, anything impactful potentially. You can just take that logic and move it out of the code that you're really testing, or make it configurable to not happen in certain scenarios. It's really going to vary based on the implementation that you're trying to substitute, but these are some things you can keep in mind. But the number one thing to remember is that scientists will run the code you tell it to run, and that may cause issues. So you need to be thinking through your experiment when you're designing it, scientifically. All right. You may have caught on to this earlier, but there's also an iteration speed penalty. So normally when I'm building something, I'm going to develop it, I'm going to test it, I'm going to show it to people. They're going to say, okay, cool, that's great, let's ship it, right? And so we deploy it. We develop and deploy, and we move on to something else. Well, with scientists, you do this, but you also then observe the results of that. And maybe they don't match quite right, so you patch it. And then you observe the results of that. And they say, okay, well, we're good. So now we're going to remove our scientist and our legacy implementation, and we're going to deploy that. And so we're adding a lot of length to these things. And so it can in turn add months to your schedule. You're not usually going to be writing science experiments for everything that you're doing, but some things that you're doing you will be using science experiments for, hopefully. You need to keep in mind that you're going to have your legacy and your new implementation alive in parallel for a while. And so if urgent bugs come in, you'll have to patch them in the legacy version, and you'll have to patch them in the new version. If new features come in, you'll have to add them to both. So just keep in mind that there is a penalty to using Scientist. That said, the benefits that it offers in shielding your users from errors, I think, are worth it. The benefits it offers in allowing you to remove this legacy debt that's around your shoulders is worth it, in my opinion, if your code is a good match for it. If your code's not a good match for it, well, let's talk about some alternatives. So the one that most people will think about first is feature flags. So with a feature flag, you have a configuration flag that says, like, hey, should I use my new routine? Okay, cool. Otherwise, use the legacy routine. Nice thing about this is this lets you quickly roll back to the legacy routine if the new routine turns out to be bad. Problem with that is that your end users will see it for the moment between when the error actually occurs and when you flip that switch to revert to the legacy routine. So users will see it, at least one user will see it because they encountered the error, and it could potentially be a little bit of a crisis for a short period of time. The other thing about this is this does incur a testing penalty. So when you are using feature flags, you need to test with the flag off, you need to test with the flag on, and you need to test changing the flag from off to on and on to off, especially if there are database differences between the legacy routine and the new routine. If they rely on a different data model or different data tables or something like that. I've seen feature flags actually cause catastrophic damage to systems because all our testing was done under one setting of that flag, and so when we needed to flip it to the other state, we found all sorts of errors because we'd not tested that other path. And so that feature flag, because we did it wrong, became a giant millstone around our neck. So be careful with feature flags, but they are an option. Another option that looks a lot like a feature flag is canary testing. So this is where you have certain users who are considered beta users. There may be users who have opted into something, or internal users, or users who are just chosen at random, and they get the new routine, and everybody else gets the legacy routine. You can do this, It's a valid approach. It can make bugs a little harder to detect. It can make your troubleshooting process a little harder, but you can do it. Another variant on this is if you're not just running one server but multiple ones, is you saying like, hey, my beta users are going to go to my this other server over here, which has my new routine, and the old version, the main version of production is going to use the legacy one. This is an option. There's not really anything wrong with it, but it is an option. So let's talk about blue-green deployment. The name blue-green really refers to two things which are not, two colors which are kind of complementary, right? You can't say that green's better than blue, blue's better than green. They're just like, hey, they're just different shades. So in blue-green deployment, you have users on one server while you're upgrading another one, and then you start to drain users from one server to the other, and you take the other one offline, right? So how this applies to our scenario here is that imagine we have legacy code running on both of them, and now most of our users are using the blue server, or all of our users are using the blue server because we just spun up the green server, and now we're going to put our new routine on that green server. And now we're going to start gradually moving users over to that green server and take the blue server offline. And things are working great, and then we find out like, oh, well, for certain types of users or certain types of inputs, we have problems, right? In this case, you're already kind of committed to the new thing. Maybe you can roll them back, start draining users back to the blue server. Maybe you can't. It depends on how you're doing your data. But either way, people have started to see this, and errors have started to come in. In my experience as well, some errors take days to be reported. And in that kind of an environment, a blue-green deployment is not necessarily going to raise that issue in a timely fashion. Okay, so those are more of the DevOps-y type things. Let's talk about more of the unit test type things that we can do to alleviate. Remember I said earlier that that part of our concerns with scientists is that we don't necessarily know all the inputs the user can do. Well, that's still true. But if we did know all those inputs, one of the things you can look at is a snapshot test. This concept I first encountered with the Jest testing framework for JavaScript. And I looked, and there's this library for .NET called Snapper, which is not nearly well known enough either. And it lets you basically take a snapshot of your current state. So when you're building out your unit test, you'll make a snapshot of the current state returned by an algorithm. And it serializes it to JSON, it saves it in a JSON file inside your test directory, you commit that to source control, and then it's good. It lives in there. And then the next time your test runs, you're comparing the results of your snapshot to your new results and say like, hey, time out, these things don't match, something changed, you need to look at this. So that is a valid option for some people. I'm not so sure that it works for all inputs, which is again, one of the main draws to me for scientist.net is when you can't really predict the types of inputs that your system is going to get. But if you can, Snapper's a great thing to look at. All right, so let's wrap up here. So the problem that scientists solves, again, is we want to make sure that we're able to cover inputs that we're not expecting. So if we can't predict the way that our users are going to use the system or the inputs they're going to put in, scientist is a good match for it. If we can't accept any sort of an error reaching the end user, scientist is something we ought to consider because that extra complexity can shield us from the pain that our users might encounter and the loss of confidence they may have. I've been talking about Scientist.net. Scientist exists in so many different languages. All of these are just languages I've found that have supported Scientist. Some of these have multiple implementations inside of their language. I'm looking at you, JavaScript, primarily here. But if you're using a language, there's a large chance that Scientist is supported for that language. And if it's not, you can always just go out and write your own. It doesn't do a whole lot of things. So it calls to the legacy routine, it calls to the experimental routine, it compares the results of the two, it publishes those results to something else, and it wraps everything else into a nice handy bow, handling errors that it encounters, and just does a nice job of it. So if you don't like the syntax I showed you today, write your own. It's not going to be that long of that big of a project. And just bear in mind that GitHub has put a lot of testing effort, and people have been using this thing and have found the issues with it already, which may not be true for something that you write on your own. All right. So to recap, in order to try Scientist, well, first you install the thing via NuGet, and then you're gonna take your code, wrap it in a nice pretty bow, write a new version of it, add an experiment that compares the two, test it, make sure that works, deploy it, observe the results that come in, and then remove Scientist and profit from your lack of technical debt. I love this library. I've been writing about it for almost a year by this point. If you want to learn more, I really recommend an article I wrote on, just go out to tinyurl.com and /try-scientist. That takes you to Kill All Defects, which is my personal blogging site, where I have a lot of articles on Scientist, including a really well-polished one from December-ish. Of course, you can also take a look at Scientist.net's GitHub repository on github/scientistproject/scientist.net. If you have any questions, please reach out to me on Twitter at integerman. You can also email me at matt@killalldefects.com, or just leave a comment here. But either way, let me know what you think. I hope that Scientist is something that you and your team will consider. It really changed the way I think about technical debt and code in general, and I love it. So thank you for watching.